Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So finally we are going to start linked list. We were following our pattern wise DSA sheet, and in this we will learn basic operations on linked list. So stay tuned because we are not only going to learn what is linked list and what are different types of problems which we can solve. Along with that, we will also learn different solutions, optimized solution using recursion or iterative. So in this video, we are going to learn what is linked list, how can we design it, and how to search elements in a linked list. So here is the first problem where we are given array and we have to design linked list using these array elements. Let's see the constraint. Constraint says array size can be 1 to 10 power 5. And what does that mean? We have already learned about time complexity, how beyond 10 power 8 operations it might give us daily. But as it is 10 power 5, so we will see how using the linear time complexity we can design linked list using array. But before moving forward, it is very important to understand the structure of linked list and also why linked list is required. As you know, array uses continuous memory allocations, so it has indexing. But in case of linked list, we don't have continuous memory allocation. Means one node can be here, one node can sit at any other locations, and how we can fetch all those nodes? By saving their address locations. Means instead of arrays where it was saving one single element, either integer or string, linked list save data along with next address location. So because of that, linked lists do not have indexing. So this is how the linked list looks like, and these are called nodes where it saves data, and along with that it also saves the memory address. So let's say the memory address is 1001, 1003 for it, and 2004 for this. Okay, so here we will have 1003, and it denotes that this node is connected to this node. Okay, now this node will save the address memory for this, means 2004. Okay, so it means if we have the track of this node, means from 1 we can go to this node 2, and from 2 we can go to this node 3, and for 3 we have no address, so we can say null. It means after 3 we have no nodes present. Now as we have our linked list data structure, so when we solve problems, instead of considering the node value and the address value, we only consider the nodes, and instead of address we consider these arrows pointing to the next nodes. But these arrow does not exist, it is only for our visual representation, so don't get confused. Now whenever we are going to talk about linked list, we are going to discuss using these diagrams and not this. Also remember, the very first node is called head node and the last node is called tail node. But head node are more important because when you give head node, or you can say when you have a track of head node, then all the other nodes are already connected with it. So when you have to return the linked list, you actually return the head node and the entire linked list gets returned because they are connected using the address. Now suppose we are given an array and we have to design a linked list. Okay, so definitely we have to make a class where the node has value and the pointer which we call next. So for a node we will have value and next pointer, where using this node dot value we can read the data, and using this node dot next we can move to the next node. So inside the constructor we will define both of these parameters. Now whenever we have to define any node, we will simply call the class by making an object. So we write type node, let's say head is equal to new, that same node class, and with the value, because in the constructor we want to send the value so that this value can be set. And remember, the address we don't know, so we will not send anything. So by default, the address will be saved as null. And whenever we have to move from one node to another, means from this node to this node if we want to move. So suppose this is our head pointer. So we simply write head is equal to head dot next. Why? Because using this address, we are moving to the next node. So now how can we make it? Okay, we understood what is linked list, why linked list. Now we also understood what is node, what are head pointers, and how we define any node. But what if we have to make this entire array, we have to shift this entire array into a linked list? So it means the head pointer should have this value 1, correct? But before that, we have to check the very first base case. What if the length of array is 0? Means we have no such element in the array. So in that case, the linked list cannot exist and we will return null. So the very first node we want to make is head and the value will be array of 0. Okay. So now we can say we have our very first node of the linked list. Name is head and the value is array of 0 means 1. So currently its next is by default null. Okay. So now what we want? We want to make another node, and also along with that we want to connect this to next, correct? So how can we do that? Can I say this null is nothing but head.next, correct? And in head.next, what if we will make another node with value 2, and in the head.next means here at this address we will save this. So now how it will look like? This 2 will come here, and now again for 2 it has null. Again next time also we have to move this head pointer to next. So now the current next will be 2. And now what we want? Again we want to make a new node with value 3, and this head.next, which is pointing to currently this null location, we want to point this. So we'll write head.next is equal to 3. But you know what? When we will move this current head all along the way, then what will happen? In the linked list, suppose you have like your head pointer is pointing to 2. So now you cannot go back because you have not saved or denoted by any pointer. So when you say print head or return head, now the linked list which is known is just 2 and everything towards its right side. 1 is not known. So that is why instead of moving this head pointer, we keep the head pointer at the same location and we rename, or you can say we make a alias of it. Let's call it current. So instead of moving the head ahead, we will move this current ahead to create our whole linked list. And at the end, as we have to send the first node of the linked list, so we'll simply return the head pointer. So what we will do? We will make a node, let's call head, and we will make new, we will call the same node function, and in the node we have to send the value. So can I say array of 0? Yes. Now after this we have to make a new node, let's name it current, and we are making an alias of head pointer because we will not move head, instead we will move our current. Okay. Now we have to make a whole linked list. As of now in our linked list we only have this array of 0, means node with value 1. So definitely the next node will start from array of 1, means second element of the array. So we will run our for loop from int I is equal to 1 to I less than array dot length and I plus plus. Okay. Now inside this we have to say कि in our current dot next we want to create a new node with array of I value, yes, and also we have to move current at current dot next. Okay. So how this will happen? See. So can I say my current is now pointing to this? Yes. Now what will happen? Again I pointer will move to this. So we'll again make a new node with value 3 and next null. Okay. Now what we'll do? What is current? This pointing to 2. What is current dot next? This null address. So we will say at current dot next, let's save this new node. Okay. So what we'll do? At current dot next, we'll erase this and we will move this 3 here. Okay. And now again we want to move our current at current dot next. Again next time we will make node 4. Okay. And its next will be null. So definitely our current is this. So as you can see from the code, current dot next, we want to save new node. Okay. So current is this, current dot next is null. Now we want to save a new node with value 4. Okay. So again this null will be removed and this will get saved here. Again we'll move our current is equal to current dot next, and we'll keep on iterating this until we make the whole array into a linked list. Okay, and our current will point to this. Now what do you think? If we will return this current, definitely this much part will be returned. Why not 1 2 3 4? Because see, linked list is all about saving your address. So wherever your node or your variable is pointing to, the linked list is only known from that location. So if you will return current, you will get 5 and null, and if you will return head, you will get 1. Because 1 has address for 2, so it will return 2 also. Because 2 has address for 3, so it will return 3 also, 4 also, 5 also, and till here. Okay. So definitely after coming outside the for loop, we can return head. Correct? So now let's run the code. My bad, I forgot the new keyword here. Okay, now let's try to submit this. I know it is very simple. This was in Java. If in case you are from C++, here is the code in C++, and if you are from Python, here is the code for Python. But this was iterative code. As we have already learned recursion, if you haven't, definitely you can check it out from here, because if you already know recursion, then definitely all the linked lists will be very interesting, because we're not going to just learn about the iterative approach but also the recursive approach. So now let's try to discuss about the recursive approach, how recursively we can create the linked list from array. So if we want to do with recursion, you know, whatever is inside the iterative code, means for loop or while loop, that we will put in the recursive function. So in the function, we will send the array and we will send the index I, so that we can keep a track of with what array index value we want to make a node value. Okay. So what we'll do, as you can see, we have in another function, we have array and we have index. So definitely we want to start from 0 index. So we'll call this function with the same array and we'll send the 0. Okay. So initially we have I is equal to 0. So definitely no base case check. But what we make a new node. Okay. Let's say node head is equal to new node with what? Array of I. So initially as the I is 0, so definitely the new node will become 1, value 1, correct? So can I say here ki my node will be 1. Now its next is pointing to null. But what I want next time? Can I say here is my current, okay? First of all, here is the head also and here is my current also. Can I say? Yes. So next time what I want in my current dot next, I want to add a new node. But remember, this new node line of code we are writing here, and we have to do this recursively. So definitely we have to call this function again, where to add the current dot next value. So after this line of code, in the iterative one, what we wrote? Current dot next. What we wrote? We wrote node of array of I. Can I say? Yes. But we have to replace this using the function call. So instead of this, we will call the function. So we'll write function array, and next time I want I plus 1. So again what will happen? This node has been created. Yes. Now we'll call the next function. Now in the next function, I will be pointing to next. So can I say I will be here? Yeah. So now again we'll create a new head. So can I say in recursion every call is getting saved in the stack? So for stack we'll write function array of 0. Okay. I'm only mentioning the index. Okay. Now next time function 1. Okay. So what happened? In 0th we created a new node with 1 value. In function 1 we created a new node with 2 value. But remember, it has not been connected yet. No, it has not been. Why? And when it will be connected? When this function will get returned back. As of now, nothing has been returned back because we are going deeper and deeper in the recursive call. Correct? Now what will happen? I is pointing to this. Again the new head will become what? New node array of I. Array of I means array of 1. Array of 1 is 2. So again I can say, let me erase. So again I can say I have one more node with 2. Again this is also head for it. Okay, and again this is also pointing to null. Remember it. Okay, Now what will happen? Again, I want, hey, this is my current, right? Again, this is my current. But we have not defined this current yet. So we can say, as in every function, head is alone, correct? Every function call. So we can simply write head.next here. Okay, remember, why we will not lose our head pointer here as we lost in iterative code? Because in iterative code we were moving ahead, but in recursive code obviously we are moving ahead, but every function call has remembered its own head. Means for very initial function the head was 1, next head was 2, next head will be 3, and so on. And when it will return back and back again for the previous, the very first function, again the head will be 1. So we do not need to remember, because our recursive code means the stack calls has remembered what was head. So hence we do not need to save or create any new pointer called current. So now what I want, again for head I want to save the new node into its next. So again I will write head.next, yes, again function next, I plus 1 means 3. So now again we'll make function for 2, and in this case again the new node which is with 3 will be created. So let me create here 3 pointing to null, and this is head. Okay, yes, let me erase this because current is not needed anymore. Correct. Okay, now again I am saying 1, 2, 3 has been created in different calls, but they are not connected yet. Okay, again now what will happen, again for 3 next we want to connect. So again head.next, again we'll make another function call, means function for index 3, and here we will create a node 4. Again repeating function for index 4 and node value 5. So again a new node will be created 4, and this will also point to head and null. Again a new node 5, null and head. Done. Now what will happen? If we will not stop, next time what will happen? I plus 1 means function for 5th index. But don't you think 5th index we don't have? So what we will do? We would like to stop the call here. Can I say? Yes. So what we will write? The base case, key if my I is equal to array dot length means 5. Okay, I want to return. So now what will happen? This will get returned. Means what will get returned? Whatever will get returned will get saved in the 5th address, 5th next address. So for 5th next address, what we want to save? Think again. Null? Yes. So what we'll do? Here we will return null. Okay. Now when this will get returned, null will get saved. Yes. And we will come here. So head.next, which was 4.next, I want to save 5. Done. Yes. So now I can say ki yes, 4 is pointing to 5. Okay. But 4 is pointing to 5, correct. But 3 is also waiting for its next. Can I say that? Yes. So now what will happen? 3 is waiting for its next. So what do you think? If we will not write anything, null will be returned. So after 3, null will get saved. But I want to save this. What is this? Again, we return to this. What is this? Can I say this was nothing but head? Because for head 4, in its next you saved 5 and you want to return back and you have head. So definitely this 4 you want to return back so that 3.next will have its 4. So definitely we will write return head here. So now what will happen? 4 will get returned. 4 means 4 with 5 will get returned because 4 has 5th address. Correct? So now in this next call, we will come here. In the next call, what we have head 3, and in head.next means 3.next, we will save 4. So now we can say ki 3.next has 4. Again, what we want to return? Definitely this 3. We will return 3, but as they are connected, so 3, 4, 5. Correct? So now we'll come here in the next call. In the next call, head is 2. So for 2.next, we want to save whatever has been returned. So for 2.next, we have 3. Okay. Now 2, 3, 4, 5 are connected. Again, we'll return this 2 as head to its previous call. We'll come here. Again, for the very first function, head was 1. Correct. So again, for 1.next, we'll save what has been returned, 2. So again for 1.next, 2 will get saved, and at the end you are returning head to the main function where you called. So initially, suppose you called function array with 0 index. So head, which is 1, will get returned, and this will finally get returned what we were expected. So what is the difference between this iterative and recursive code? In iteration also time complexity was O of n? Yes. In recursive also O of n? Yes. Then how and which one is better? See, trying to understand the recursive code is very important, because the better you will be at recursion, the better you will be at DP and backtracking concepts. But in this case, which one was the best solution? Iterative or recursive? Obviously iterative. But why? Time complexity is same, but space complexities are different. In iterative code, you have not used any extra space. But in recursive code, you actually internally used a stack to save your function calls, which uses or which takes extra space, which is O of n. So hence, iterative code is better, but again, we will try to learn the recursion in every approach. So that is why we have discussed both the code. So here is the code what we discussed. Now let's try to run the code and let's try to submit the code. And that's it. So I hope you understood. If yes, we can go in the sheet and we can mark the design linked list question as done. So in the next video, we will learn about how to search, how to insert at different positions, and how to delete from different positions. So stay tuned. Let's meet in another video with some more interesting videos and topics. Till then, keep learning, take care of yourself and your family.